Okay, I'm trying to add this feature, but I am not done yet. So I debug. Oh, let me clear the screen. Okay, I added this show hits button here.
Is that?
It's not great UX, but basically if you highlight a line in the debugger, you click on show hits.
Oh.
You get all the hits of that line throughout history.
Okay.
But you just see and you can click around. Like if you look at the timeline,
Uh-huh.
you can jump to. Oh, I guess I broke it. Uh, but if it worked, then you click on the line, and
Uh-huh.
then you would jump to that point in time. So each selection is a point in time.
Uh-huh. Oh,
Like
I
each
see.
line here is a point in time. If it weren't for the bug, then you can click on any of these numbers, and it like the step number would change to that one. It would jump to that point in time. Okay.
Yeah, that makes sense. That's
Um,
mhm.
so, but the problem with this UI is you see these numbers, which doesn't really mean anything to you. So, um, so I wanted to show you some context information. So,
Mhm.
so I did a separate prototype because it's easier to implement something small.
Okay.
Um, so I think it's C code 2. And you need to provide a code file number. So you would, let me see. Yep, let me open this file up. Okay, so you find a file. I'll go OUI core.
Mhm.
Uh, and we go for the same line, which is I went for here 370. So on the command line, and I say 12. OUI core is 12, and then line 370, and then it'll print out that same snapshot number, but also show you some context information, which in this case is some attributes of the event object. Um, that
Oh,
was that was on when you were basically when you were on this line. It shows you a little bit of what the event object was at that point.
so how do you decide what kind of context to show?
Yeah, that's something that's kind of interesting. Uh, um, I'll I'll show you the second feature that I want to show first, and then I'll
Okay.
explain how this works. Because
Okay.
the second feature also uses this. It also uses the same infrastructure.
Okay.
The second one is the naming is really convoluted because I'm really being sloppy right now. That this is a quick and dirty prototype that I'm not gonna use anymore at some point. But in this one, what you do is this one shows you all the times that a particular function has been called. So I'm gonna choose, say, the add child function. Oh no, I want to go to the so 242 is what I want, and yeah, so it's gonna print out every single time that the add child function has been called.
Okay.
and it'll actually print out the line that called the function, which is sort of like not the first line inside the function, but the one step previous to that. So you can see the line that actually called the function, and then also it again shows you some context information. It shows you some attributes of the parent parameter, which is the first parameter, and then some attributes of the child parameter. And then that way you can scroll through this list, and you actually get some useful information about what things are getting into the function. And maybe find what you're looking for just by scrolling through.
Yeah, I like that.
Yeah, so and it's not as good as I would like it to be yet. The algorithm that decides what information to show. So let me explain that algorithm, and maybe you can brainstorm possible ways of making this algorithm better. Okay, so maybe I'm gonna sort of sketch out the idea first, before showing you any code. Okay, so let me see. Okay, the idea is that like at any point in time, let me go back into the debugger. I go in here. At any point in time, there's a context, like all the state at that point in time. There's a context, and in addition to the state, there's also the context of the code execution, as in like who is your parent function that called into you, right? So that's called the backtrace or the stack trace. So I guess two pieces of information is like, one is the variables, or maybe the state of the variables. And then another is the context, execution context, which is like basically the stack, the state of the stack frame. And actually, when I was first thinking about this solution, it was not applied to this problem. And this initially, when I was thinking a lot about this, I was more thinking about if I wanted to display like that call, that call, the first C code. This one. I don't know if this is even gonna. This might take too long. Let me try. I'll go with this one. I was thinking actually. I want to make this more useful by showing you the actual values of like maybe like this is a recursive call, and this is gonna end up being fib of 8, right? So I might want to show that, and this will end up being fib of 7. Like having these be replaced with or supplemented with the actual values at the time. It will be useful for you reading through this and understanding it. But the problem is, what if this was not just a number? What if it's a composite object that has multiple attributes in it?
Right.
It's very difficult to inline a large number of information, a large amount of information, right? But I still want this feature. So how can we do it? I thought about showing the unique identifying attributes of the object. Like maybe if the object was a person, like if it's like, I don't know, add person, and then you pass in a person. This is the code, and then I'm gonna show person ID equals 5. Name equals Toby or something, right? But the person might have other attributes, but I'm not gonna show that. I'm gonna show the most distinctive features of person.
How do you know that's the most distinctive feature?
Yeah, so exactly. So I thought about how can I find the most distinctive feature. Well, I could do it if I can look through all of the persons in my database and compare the attributes.
Well, but I mean, would that like make it slower if you have to do that?
Yeah, it will make it slow. So if there's a large number of it's actually not all persons. It's all historical persons, because all versions of the persons we'll look at. But yeah, it'll be slow if there's a lot of them to look through. So what we could do instead is random sampling. We randomly pick some of the persons from the entire set of historical persons. And then out of the sample, we're going to compare them in order to find the most distinguishing features.
Well, to me, if we could like well, if it's like, oh, you just show me a equals to fib n minus 1, and then I can like click on n, and then you will show me the value, but that will make it less like direct, because
like have an interactive feature to let you choose what attribute.
Yeah, but the thing is, if you have to click on n in order to see what the value of n is, then I cannot just browse all stuff to find what I need to find. But at the same time, you can have a search functionality.
You can have a search functionality. Yep. Yes, those are all possible. Yeah, I'm planning to have like a conditional kind of, let you type in a conditional and only show you those. But I think showing the values will still be very helpful if you can manage to pull it off. So anyway, so this is the prototype that uses that concept. So indicate, so go back to the first example where it did this. In this case, what I actually did was I did a heuristic, which may or may not be good, but
what is that?
The heuristic is I used the line of code, which is this.
Okay.
And I parse out the variables that are referenced by this line.
Okay.
Which And I decided to ignore the attributes. So basically I just picked out the variable event from here.
Mm-hmm.
And I show event. There's also a context, which is who's the parent call into whatever function I'm in, who's the parent call. I put that context as a potential candidate for being displayed here. But it turns out that that was not as good as these attributes of the event. So it decided to pick the event type, the event positions X and Y. And let me show you the code. So I have this get distinguishing attributes function, which it picks 10 samples.
Okay.
So that's the random function to generate an index into the array of snapshots. And then there's a bunch of stuff, but essentially what it does is for each, I'll do some, actually I'm going to, let me see if I can put this in the debugger. This is, actually I can just go to C code 2 now using the shortcut, the quick launch. Okay, so let's go to this get distinguishing features function. Oh, there it is, I think. Yep, right here. All right. So get a random number 18. And we're gonna get a snapshot. So this is one of the snapshots, but that's we're gonna grab some variables though. Oh, first we're gonna get the context. The attributes is the thing that is gonna have the things to be compared to find which ones are the distinguishing attributes. So these are like all the attributes. I first put the context here, which is like, hey, I was called by the start function in this GUI2.py file. And then here we collect the variables into this attributes. So and so at the end we just have one variable, which is the event, and we have all of these attributes within the event put in here. But then I score the attribute uniqueness,
That's cool.
Which let's see, which I accumulate that into this scores dictionary, which was initialized here. So we start with a scores dictionary, and then we go through each sort of snapshot, and each snapshot we get this attributes object that has these things in it, and then we sort of accumulate it into this scores dictionary. And at the end, when we have everything accumulated, we have these scores. So basically, each of these, I sort of expand the path, or not. Yeah, I make the nested paths sort of this long, lengthy path string.
Okay.
And then for each of these attribute paths, I have a set of all the different values that I have seen.
Okay.
Throughout those 10 samples.
Okay.
So like sometimes I get mouse down, sometimes I get key press, sometimes I get mouse up, and so forth, right? So and then the context, but the context is always the same. Because I only get called from the start function, so the context didn't change. So that's not going to get a high score. But the ones that have a lot of distinct values, I basically pick those. The key. This is the key press. The key presses. I press I, P, and H. And so forth. So as you can see, like this is the best one, right? The event type is the best one. And the X and the Y are probably the next best. This is good too, but it didn't get picked. So yeah, so that's how it works. And at the end, let's see, I picked the attributes to use, and those are the attributes to use. And I do that by, I just I sort them and then pick the top 3, basically.
So what if this line has like 5 different objects? Then what are we going to show like one attribute for each one, or is there a score for that too?
Which line has 5 different objects? There's attributes to use?
No, if like say the line that you're showing in the timeline, because this line only has one object, which is event, right?
Oh yeah, there could be more, and in which case it will go as in a separate variable under variables.
Okay.
As another variable. And then what happens is it gets scored the same way. Like it's not the variables that are getting scored, but the attribute that's getting scored. So because at the end you get these.
Okay.
You always go down to a leave attribute, which is and probably gonna end up being a number or a string. Because if you walk all the way down and that's still a composite object, those are not gonna get a high score because I don't know how to compare. Like I have a max depth of how deep I want to fetch. Which is just 1 or just 2 at the moment.
Okay.
So it doesn't go very deep, and once it gets to the max depth, if it's another object, it's not going to fetch the values of the object. It's just going to say this is a mystery object, and then the problem with a mystery object is it's just going to, when you compare 2 mystery objects, they're usually going to be the same.
Okay.
Yeah.
Interesting.
So the only ones that will be different will usually be like the strings, the numbers, and the booleans.
That makes sense.
So yeah, so that's how it works. Yeah, and then once you get the attributes to use, now you go through all of the snapshots, not just the randomly sampled one, and use those attributes to select the values from every single snapshot and display them.
Okay, gosh. So you have to make a SQL query.
Yep. In both cases, I even to get the distinguishing attributes, I had to make SQL queries there also.
Gotcha.
Yeah. So, yeah. So that's how that works. The one thing that sometimes it's a little weird is well, this case is not showing up as much, but sometimes it's a little weird if it picks Y, but it doesn't pick X as a distinguishing feature. And you're like, oh, okay, I can see the Y, but I can't see the X.
Okay.
And also here, the key press events don't have X and Y, and they just show up as none. that's a little weird. They don't actually have X and Y. They actually don't have those property at all.
Uh-huh.
I can probably just get them to not show. I can probably figure out that case and just not display them.
But it's there because X and Y got higher score because of other events. But in this case, it doesn't matter. Okay.
Oh, actually, I should have included none or non-existent as one of the values in the set, and then it would have had even bigger score. Yeah. But yeah, sometimes it sometimes well, I don't know. Like it probably can be improved. Like those, like sometimes it's just weird. Like if you see just a Y attribute of an event, like maybe it decide. Like I have seen before that it decides not to display the type because the Y attribute was more distinguishing than the type for some reason.
Well, I think in this case, it's like a combination. I mean, if you're a human, you look at this, you know how to describe an event. You have to have a type and X and Y because that's what makes sense for an event. But when it's an algorithm, you don't really know. It's like a combination. Oh, you have, if all the events have the same X, but Y is different. Okay, Y is more distinguishing, but X is all the same, so it's not distinguished. But it would be nice to have X even though they are all the same.
Yeah, that's a human knowledge.
Yeah,
has to be factored into it. There's in Python there's a thing called wrapper. I think you might have seen it. Like in a class. Let me see. So we could potentially use like wrapper. Like you implement the wrapper method, the thunder wrapper method, and then you just return some string which you deem is the representation of that object as a string. So when you do print the object, then Python knows to call this method to get the representation of the string. If we I don't have the maybe we can use that, either use that directly or use a representation or use that idea. So allow developers to write a method that tells me what are the attributes that are a good representation of your object. And then I have the debugger display that. If the debugger could display the wrapper and just, yeah, maybe using the wrapper is an idea. And then I just print the wrapper here. That's possible. That is an idea, because that's sort of what wrapper is meant to do. It's for when you're debugging and you just want to print out the object. That's what wrapper is designed to do.
Do Python developers use this functionality a lot for the wrapper?
Yeah, they use it enough. It's a well-known thing. Probably not everybody does it, but if it's like it's well-known enough that you tell a Python developer implement wrapper, they will be comfortable with it.
Why do they implement it if it's not for debugging purpose? For what is the reason that they use this in normal cases?
It is for debugging purpose.
Oh,
It's mainly for debugging purpose. Like if like my person, I make a class person name age. then you might write a wrapper like, dang it. Okay.
Oh.
Well, I'll do it here. Then you write a wrapper like return person. Just a little. Something like this.
Mm-hmm.
And then that's just a string that represents what a person is. But yeah, that's a possibility. I will consider that. But let me see. It might not be super easy to implement this into the debugger because that means I'm gonna have to load the code, which currently I'm not doing that. I have to load this person class and load the code of this wrapper and call it from their source code. And currently I'm not doing that. Currently I'm just reading stuff from the database. Even though I have the code here, I have all the code as source code inside the database. I'm not so figuring out how to load the code might be a challenge.
Okay, so basically you have to execute part of their code to do this, but you don't do it right now. Okay.
Yeah, and if I have also considered, yeah, in order for them to customize some aspect of the debugger, which is what we're talking about, I'll no matter what, I will need to have a way to load their code. Like I even thought about, like if they were programming a chess game or a tic-tac-toe game, their board might be represented as an array of values or a list of values, but they might plug in a UI component instead, and then they can display the board as a game board inside my debugger.
Oh, that's cool.
So
but they have to write a UI just to do that.
Yep, they would have to write the UI and plug in the UI module into the debugger. How to make the wrapper? Maybe that's something I should think more about, like along this path of. Yeah, well, yeah, I think that's a good path to consider. Yeah, let me think about that. Yeah.
Do you think it will be a security concern if you execute their code? Or not really? Like you execute their code in a way that they didn't execute. Because now they execute the code. Okay, we have the trace of what the path of the code that they executed. But if we get the handle of their code, then we can run their code however way that we want to. Would that be an issue or not really?
I guess this is a development tool, so we're already kind of deep in their stuff. There's, could this be used as an exploit by an attacker? Maybe. That's more of the question. Like if an attacker is trying to attack somebody, can they use this as an exploit. They can use it as an exploit by updating the source code of the people that they're trying to attack. But if they can already do that, there's very little they can't do anyway, right?
That's true.
So, yeah. It's not any worse than it already is, maybe. Yeah. But that's a good idea. Yeah, maybe I do need to think more deeply about just executing the code inside, loading the source code inside the debugger, like how that can be done. It might not be that easy, actually. Maybe I go find sections of code and just load that section. But the code might have dependencies though.
Yeah, how would you do that? If the code has dependencies.
Yeah, this might be difficult. Because a normal debugger has the actual code running live, and so the objects are already live. You can already call methods on the objects because they're already live objects. But my debugger is not that way. My debugger is nothing is live. It's all like a it's all a fabrication. It just shows you the previous state, and that is actually a very real weakness of this scheme, because well, you can implement it, but it's not directly. You cannot directly execute an expression, like it's like you can't do like event dot type plus equal something. You can't do an expression like that in the debugger, because that would be executing code. And I don't have a way to execute code right now.
So does that mean if you do want to execute code, you have to execute it again simultaneously?
Yeah. Not simultaneously, just at the point that you want to, like if I wanted to give the user a console that they can type in code, hit enter, I would need to have the Python interpreter running inside the debugger. And I also need to somehow, because there aren't real objects that are loaded. I'm just showing you a historical representation of the object. So in order for me to execute code, I have to fabricate the object. I have to create like a clone of the object at the previous point in time.
Yeah, well, I guess this is different from the wrapper case, right? Because in this case, if what you want is a console and they can type in event dot whatever equals to like whatever, and then return a value. So that you do have the value of the event. So you just need to.
Yeah, I might write an interpreter. I might have to write an interpreter that parses their statement and then go into my database and actually interprets their statement and gives them the answer.
Right, but I feel like this is still a different problem of the wrapper, because the wrapper will never be in your database if the execution path never call the wrapper, right?
Yep. I'm gonna need to implement the wrapper or execute the wrapper at a later point in time.
Yeah.
And I guess one way to do it might be, well, the obvious way that you would go about it and is you would actually load the code the way it needs to be loaded into Python and actually have the Python object there and then call wrapper on it.
Or can you change the Python interpreter to look for wrapper when it's like instantiate each class? And then so that you always have the wrapper of each class there on hand. If what you want is just the wrapper.
You mean, but you have to call the wrapper method though in order to get
right. Can you do that in the interpreter or not really?
That would be very expensive because every time the state changes, it can change the output of wrapper. So you have to call wrapper again every time any state changes, unless you have some smarts that knows what attributes the wrapper is dependent on. But that's hard also. So another way might be I implement my own little Python interpreter that tries to execute the code inside of wrapper. But maybe it's not a full Python interpreter, or maybe it is. Maybe I just use the Python interpreter, but I just pick out the code inside of wrapper. Or maybe I just use maybe I just implement an interpreter, implement my own interpreter. I use the Python parser to parse the code inside of wrapper, or just pick that code out of wrapper, and then I walk the AST myself. But then the problem is the wrapper might be dependent on another helper function, maybe that comes from the outside.
Oh yeah, what are you gonna do?
That's hard again. So it's definitely not an easy problem to solve. And maybe that's why I've stayed away from it. But that doesn't mean I shouldn't try though. I'll keep thinking about it.